Okay, we're live, I think. Our systems are green. The recent project. And this is gonna be one of the upcoming projects with this vacuum fluorescent display. Then the MTZ VFDCLK, the multi-time zone vacuum fluorescent display clock. Hi, meow! Meow, Alana. Nice to see you here. Yeah, it's loading and a bit of old school hot metal because that was my workplace, that was my project back when I worked for the Book Art Museum in Łódź, and I developed the computer control system for the monotype composition caster. Pretty interesting stuff. The history behind the monotype composition caster computer control interfaces, it dates back to 1960s when the Monotype Corporation invented their original system, probably using the transistor logic than an integrated circuit logic. Their computer system, their typesetting system used the data storage that was devised back in the late 19th century. The monotype 31 channel perforated paper tape that was prepared with the keyboard and then put on the casting machine, and the casting machine passed compressed air through the holes in this ribbon, directing air signals to miniature pistons, miniature cylinders, where the plungers were risen and then came into way of tongues, which were then coupled with certain levers, putting a matrix case in one of the over 200 of positions. Pretty complicated, but absolutely brilliant. Yeah, well, Ray, linotype and monotype, they were pretty much concurrent. Linotype used a completely different system than monotype because linotype had 8 notches on the matrix, and the linotype system put a row of matrices together, then cast the whole slug, the whole slug of metal as one piece. And monotype, on the other hand, did cast a row of text composing of single types. They have one sort of type somewhere around here, I thought. I did. Maybe it's on the bench. One moment, please. And if you take a look at the nick on the sword, it's rectangular. It's pretty characteristic of the monotype type, and sometimes type foundries that in fact operated the monotype casting machines had special molds with round nicks to make their customers think that they were producing the old school foundry type, because customers often thought that the monotype type was inferior in quality. It sometimes was, because the alloy didn't have as much antimony as the old foundry type alloy. That's because the makers wanted to keep the melting point lower than the old thing for technological reasons. And this had the disadvantage of the alloy being softer and not as durable. But then the monotype process, it involved casting, printing, and then remelting the spent type. It was devised with print shops having casters at hand on premises, and keeping the metal circulating. Yeah, antimony, yeah. SB, stibnium. And yeah, brass masters. Well, the matrices, they were made of bronze. Bronze or brass. I don't exactly know which one. Both the linotype and monotype matrices. And the type was made of an alloy of lead, antimony, and tin. And by the way, there's also a common misconception about the hazards involved, because it is often thought that the lead vaporizes and you breathe it in when working with hot metal typesetting. And it's not really the case, because the metal is close to the melting point, so it would take a few more hundreds or thousands of degrees to evaporate it, because the metallic bonds are pretty strong. But there was another hazard, because the monotype composition caster has the mold right above the melting pot, and the mold is lubricated with oil. The oil drips on the surface of the metal, and then decomposes and burns down, and this emits all kinds of volatile organic components, volatile organic compounds that are most likely carcinogenic, so you'd better not breathe in too much of that stuff. It is best to make a system for extracting the fumes, and that's what I did back when I worked for the Book Art Museum. Yeah, shaving and cutting operations. There's an echo. Interesting. Let me check. I guess it's because the microphone is pretty far away from my mouth. Might be... Yeah, don't forget having to read backwards, putting the page together, of course. The compositors usually turned the composing stick or form around so that they had the uppermost lines closest to themselves, and then they could read them left to right, still upside down, but it was easier to read them this way than right to left. I'm pretty good at reading right to left. I got a little story from my childhood. Back when I was at the kindergarten, I was taken to a psychologist because my mom noticed that there was clearly something off with me. It turned out to be the autism spectrum, and no one could really tell what was going on. But they noticed that when I was playing, when I was at some table or desk, I was reading a book upside down, upside down, right to left. and I was pretty comfortable with doing that. I always was a very curious kid. And yeah, I also had all kinds of special interests, mostly for cables and plastic tubes and pipes and that sorts of technical stuff. Then it was also chemistry and some physics. And here's one for you. And yeah, and some pop culture, some games. Typical stuff. Oh, and I guess this little thing that I want to show you on this stream, the vacuum tube tester that I made something like 2 or 3 years ago. I'll show you the tube measurement and how the device looks inside. Corky? And probably quirky as well. And also one thing that I want to show you is the radioactivity lamp. Let's change the color on it a little bit. Doing it from my laptop. And maybe also the times and the speed at which it changes. Oh yeah? Blaring like a sign in a nuclear power plant. Oh no, it's gone active! Yeah. Sounds like a nuke button too. Oh, that's a good one. That's a good preposition because, yeah. What if I got myself a typical emergency stop button, and then put an ESP8266 in it, and programmed the ESP to send a bunch of messages over MQTT to change the color and the speed of the radioactivity lamp. Because I finally got the MQTT control of this lamp to work. It uses a Node MCU module, which is ESP8266, and it drives 4 LEDs. Those LEDs are pretty similar to Adafruit NeoPixel. They use the same control and communication protocol. I drive them using the NeoPixel library. I got one of those things turned on, and let's look at it. That's how it looks like. Just okay, it fell down below. It's just an RGB LED with a control chip that does all the work. Wonder if I can recover it. Time for a deep dive. Deep dive is complete. No, Bubble, it's not a CRT. It's not a CRT at all. The controller chip is LM2811, or is it something different? Or EM2811. Can I have a datasheet on that one? Well, I guess this is an equivalent of WS2811. That's a pretty common chip. No, no, Eduardo, you're not sidetracking me. I think that we'll be doing the rectuing stuff for half an hour or an hour still, and then get to the bench. Yeah. So to change the change the topic a little bit, because a week ago I was doing that little amp, and after I put it together on the bench on the stream, it turned out that I put the sub-chassis the wrong way, and it was I took it apart, and it was not the plate that I thought I put the wrong way, but the other one. So I had to take it apart, put it together the different way, and then it turned out it was worse off than before. Then I reversed that, changed and changed the position of another plate, the one that I've got the tube bases. Let me grab it. So it was not all the stuff with respect to this plate that I had to put in my reverse order, but it was just this plate that I had to turn around. So I guess that today or tonight it will be time to continue building this amp. Yeah, that was a good way to say this. Just some lost time, and I wasn't even all that angry about what happened with this amp, because it's... Yeah, Kitty! Oh yeah! Hello, Kitty! Meow! Meow! He's a movie star! Coco, you're such a movie star! You're gonna be the celebrity. I bet that with the cat appearing, I bet that I'm gonna have 1,000 subscribers in no time. Yeah, hey Ola. So that amp, we'll continue building it, and as for strange things happening during amp building, I'm a subscriber at Skunky Designs Electronics. She's quite nice. She's building hi-fi amps, and quite nice at it, and she did one thing wrong with an amp she was building. Was a Eagle 84, I guess, push-pull amp that had a very bad case of asymmetrical clipping. That it turned out that she got the grid leak resistor wrong. Instead of 470K, it was 1K. That's why one of the output tubes almost didn't get the signal because together with the filter cap, it was it was a high-pass filter that didn't want to pass the audio frequencies, and that's how only one half of the signal was amplified. Yeah, you can always make mistakes. It's important to learn from them, but sometimes it's fun to learn from strange mistakes. I also know something about it, having been building amps for almost 20 years. I don't do it on a daily basis. I just build an occasional amp from time to time. I don't make that many of them, but I did make amps. I did service amps. The vacuum tube stuff. This is the favorite thing about old school electronics. Building the new projects and then troubleshooting them when the time comes to fire them up and something is wrong. Yeah, make sure the cable you cut is in fact dead. I guess Chipmunk, you got zapped. Yeah, from a cannabis grow house. Wow. Yeah. Here in Poland, we call this kind of situation NPEE. That translates to illegal power draw. Yeah, I guess that happens all over the place. And yeah, when I worked on all kinds of electrical wiring, I first test the tester to make sure it works. I tested on the non-live wire, and when that is confirmed, I can use it to test whether the circuit I'm gonna work on is in fact live. You can never trust your tools blindly. Yeah, Ola, I guess that of course some are more geared towards the goal, but yeah, it takes some fiddling, and maybe you have to make a custom output transformer to match the internal resistance of the tube you want to use. And the internal resistance, it's a function of the tube's operating point and its construction, its parameters. It depends on the voltages on the grids, on the plate voltage, and also some other stuff, and of course the tubes emission, whether it's still good or too badly used to be of any use. It also matters greatly because tubes that have lost emission for their use, they won't perform all that well. But generally, you can make an amp out of almost any tube, but sometimes the parameters won't be optimal because the plate's admission power is one thing, then the capacitances and noise parameters are a different thing, and yeah, curious cat, of course. And then the transconductance, that a parameter that says how much difference in output current you'll get from a difference of 1 volt on the control grid. It's also a different thing, and basically for designing an amp, you need the characteristic curves that you can find in tube catalogs, and with them you can graphically determine the tube's operating point and the plate voltage that you're gonna work with, the optimal one for the power you want to get out of the amp. Also, the voltage amplification factor, if you're going to build a preamp, because with the output stages, it's mostly about the current amplification, but of course with the common small preamp tubes, it's also current amplification, and then you just multiply it by the plate resistance to get the voltage swing. Yeah, the designing the amp. There's also some software that can help you with that. I guess that the TubeCAD, from what I remember, or the programs from Duncan Amps, they were quite helpful to get things going. I also know the Polish program named ECC Lab. But generally, I think that the best way to do it is by using the chip characteristics from the datasheets. Hi, thanks Eduardo. Nice to hear that. Yeah, I try as I can to be quite smart and knowledgeable. Not sure how I am doing at that. Not just a pretty face. And that's with no facial feminization surgery. Not going for that one. Well, I can't afford one. And even if I did afford, I still don't know if I would. I'm pretty happy with the HRT, the hormone replacement therapy results. So why go for anything drastic if it's not needed? Yeah. Hey, thanks a lot. And lately I've been doing a little bit better because I found a job offer at the local art gallery, and I'll be going there. I'm going for an interview on Tuesday. It's a technical specialist position at an art gallery. Hope it's gonna be fun. Even though I think it's gonna be some physical work, like lifting some heavy loads at times. Well, I think I'm gonna do okay with that one. It's more important for me to work at a place where people are open-minded towards someone like me, towards queer people and autistic people, because I'm pretty afraid of construction work. Though I'm a licensed electrician, but working in that culture, I just feel it's not really the thing for me, because I also have some experience working at construction sites and remodeling the flats or offices. You never know who you're gonna work with, and sometimes it can be traumatic. Sometimes prejudice and violence Yeah, it's a shitty situation, and I really want to avoid that with the with the place I'm with the place I'm in with the mental health not being all that good. I'll just try to look for something that's not gonna harm me any further, and that's gonna help me, and that's why I applied for the job at a place where I could expect decent people, sometimes even contacts that could help me with some things like meeting some artists and all that. Got some experience from my old city, having done lighting for the festivals, like the Wash Design Festival and the Photo Festival. So that's an asset for me. And also, having worked for a museum, I just feel that I'm not made for the rat race that's all over in the enterprise or business or corporate thing. I'm more like a non-governmental organization type of person. Like there's different stuff for everyone, right? At least there should be. Like with my processing issues and with my low resistance to stress, I won't be doing well in a fast-paced environment, especially if there's a lot of sensory input. Because I've been there and I've done it, and that dragged me down. So at this point, I just know who I am, and I know who I am all too well. On one hand, it helps protect me, but on the other one, it limits my choices. But at least I'm not all that easy to be tricked anymore, to have an illusionary notion of how things look like with me. So I have to take this into consideration. Okay, I guess it's something like 10 minutes until we get to the bench. And it's another thing, a different thing worth mentioning in this short time. is that today was the scheduled launch date for the Cygnus mission, the Northrop Grumman, ISS resupply mission number 18 or 19, if I remember correctly. It got scrapped, and next attempt will be tomorrow. I was gonna watch it out of curiosity, but might not be all that spectacular. The really spectacular stuff that I saw recently, well, I didn't see it live, but I saw the replay. It was the USSF 34 mission, the SpaceX Falcon Heavy launch of a satellite, and the launch succeeded. But what was absolutely fucking brilliant was the boost engine landing, because the rocket had two boost engines that landed on their designated platforms, and it was perfect. They touched down in the precise spot. Nothing tipped over and nothing got damaged. Perfect landing. I'm absolutely impressed by how they did it. I wouldn't even think a thing like this would be possible. And that's the thing that China should really look up to. Instead of just shoving the rockets anywhere, no matter if people live there or not. Like China, they don't give a shit about where the rockets land. Yeah, fire alarm and mission control. I think there was a fire on the launch platform, and the personnel had to be evacuated. Hi Al, nice to see you Al. And yeah, let's see tomorrow, because they are gonna repeat the launch. I hope everything is okay by then. And of course, next week we're gonna have Artemis 1, and I hope that France gonna do a joint stream with Dave Jones. like they did on the first launch attempt. Of course I'm gonna be there. And if not, then I'm gonna watch it over there at NASA Spaceflight. Because yeah, what got me into becoming pretty new, but well, beginner. I'm really a beginner as a space nerd, but what got me into it was the James Webb Space Telescope launch. And yeah, the radiation lamp. Yeah, like now I give it. Hi, hi, Joanne. Nice to see you here. of, Not Jason, James. It's not. It's James, but yeah, those pictures from the Webb telescopes. Every single one of them is a thing of beauty and a joy forever. I absolutely love looking at them. Yeah, next Artemis 1 launch attempt early in the morning for us Europeans. I guess so. I guess it's gonna be at. Was it around 8 a.m.? I'm not exactly sure. Let me check. One moment, please. Artemis 1 launch time. Okay, NASA website only has the date. 507 UTC. Oh damn it! It's gonna be around 6 a.m. here. I better set up my alarm clock, cause I gotta see that. I absolutely gotta see that. That's the moment worth of getting up early. I gotta see that one. Yeah, midnight Easter time. So I guess that since it's gonna be midnight local time, I guess that I wouldn't be able to see all that much on the stream, like with the night launches. But still I could see the fire from the engines. Hopefully only the fire from the engines and not somewhere else. Yeah, daylight change. The last weekend was the time travel night. Get in the DeLorean and just crank it up to 88 per hour and off you go. Back to the future. By the way, the Doc Brown's lab, I absolutely love that one. My lab is a little bit like that one. All kinds of old stuff and another mess. Nah, Maris, just how many times can it get delayed? I hope we're going this time. Because it's been scrapped enough times for me to grow impatient with it. Yeah, so it's gonna be time to get to the bench. With the vacuum tube tester. And the radioactivity sign can go to the side. And I've got two EL84 tubes that I want to test. So let's connect it. And let me open the chat in the laptop at the bench. Okay, everything seems to be okay now. So this is how my vacuum tube tester looks like. I built it in 2020, and I used a project from a magazine called Practical Electronics. In Poland, it's Elektronika Praktyczna. The English translation is Practical Electronics. Got the schematic for the tester here. The main printed circuit board is from that project. Sourcing the components was quite difficult because this was not really sold as a kit. It was sold as a board with a programmed microcontroller, and all the other stuff, all the other parts, you had to get yourself, which is pretty hard. And I also did some modification. Oh, thanks, Eduardo. I did some modification to the design, not the design of the board itself, but the peripherals, all those bases, and the selection matrix here. It's really my job. So because we're gonna measure the EL84, I need to find the pin assignment. This would be this. 1 is no connection NC. 2 is control grid G1. 3 is cathode. 4.5 it's heater. 6 would be no connection. 7 would be the plate. 8 would be no connection. 9 would be the screen grid. So I don't have to change anything because the meter was previously set up to test EL84. Let's turn it on. Adam Tatuś and Tomasz Gumny are the original designers of the circuit and software. I might do some development work because I have the source code for the microcontroller's firmware, and at some point I think I will do some programming work to port the code to a different microcontroller, because this tester uses an Atmega 32. It's got pretty limited memory, especially the flash memory, because it's what stores the nominal test data for the tube. It stores quite a lot of tubes, but not all of them. If you push the start button and hold it, you can preview the test data and the parameters that you should get. And in order to start testing the tube, put it in the socket. If you need to select a different one, then hold the start button and turn the encoder until you find what you're looking for. Oh, hello, kitty! That was kinda scary. Yeah, let's stick with EL84. Now, the feline presence on the bench while the tube is being tested, it's a little bit annoying. And let's press the start button, see what happens. The heater voltage is being gradually raised to the nominal value. Then the tube is preheating. Then the time measured here is the time until the end of the test. It's gonna be 2 minutes from now on. But the test itself, it takes something like half a minute. Most of the time is used for heating the tube and stabilizing its parameters. So at this point there are no voltages on the grids and on the plates. The only thing that gets voltage is the heater. Yeah, Kitty needs to supervise the situation. Yeah, a cat tester. No. Wait a minute, a cat tester? I've got a different cat tester. Climb his territory. Standard cat paw. Okay. The control grid voltage is set. Then the plate voltage is set. And the screen grid voltage is set. The meter is measuring the plate and screen grid current, changing the voltages on the plate and on the grid, and then measuring the derivative parameters. Let's do it again to see if it was not a fluke. It's something like 18 milliamperes per volt transconductance, which is pretty weird. And the internal resistance, it's also pretty off. I wouldn't really trust this tube. This is the tube testing witch, and what I have for you today is, yeah. But it's not gonna take me 3 seconds to test the tube like it takes 3 seconds for the lockpicking lawyer to pick a lock. And of course, this is not a fluke. I don't think that Fluke has ever made a tube tester. I guess it was not that era. Yeah, the big red button. The big red button. Let's try again to see if it was not a nuke. It's EL84, a very common type of tubes in the audio world. Both hi-fi and guitar amps often used EL84. Very popular. Those two were made by JJ Electronics in Slovakia. Then the factory that was formerly the Czechoslovak Tesla brand Tesla was a union of Czechoslovak electronic industry, kinda like Unitra was in Poland. And they did all kinds of stuff from typical AM radios and TVs to test equipment and radio communication gear. Yeah, the current is around 40 milliamps. Just don't touch any of those contacts or you will be dead. Interesting. It gives me somewhat inconsistent measurements. But I guess that those tubes they are pretty well matched. Let's turn it off, take the tubes out. And it will be time for the most interesting part, which is what's inside the tube tester. Yeah, yeah, I guess so. I did it all by hand. Yeah, explicit is better than implicit. .007 vibes. Oh wow, the case is not that great in quality. If it was only made of real deal aluminium, but it's just a very thin layer of aluminium or aluminum over a thin plywood, so that it looks the part, but it's not that sturdy. Time to lift it. I will also have to take a look at the back side. And I can lift this, showing you how I built the thing back before I had my trademark Keritech nylon string to make the cable loom. I used the black thread. Yeah. Translated for dumb Americans. Yeah, breadboard plywood. Yeah. And yeah, I did it all by hand. I assembled the PCB all by hand. Let's check if there's charge on the electrolytic capacitor. This one is safe. And this one is also safe. Not sure if I really should take the PCB off its standoffs. I think I will. Just to show you what a thing of beauty and a joy forever this is. Disconnecting the connectors. I need a longer screw on that one, it seems. So here's the back side, and here's the component side. This is the big ass 330 microfarad 400 volts electrolytic capacitor for the B+ supply. This is a 10,000 microfarad 25 volts electrolytic for the heater supply. This is a heatsink with a bunch of MOSFETs because the device uses PWM for voltage adjustment. The relay here is for changing the measurement range. No, this one is for switching the plates between first and second system in a dual system tube like 12AX7. This one switches the plate current measurement range by switching the shunt resistors. This is the Admega 16 microcontroller. This coil together with the capacitor, those capacitors and this diode, it's for the voltage converter on the heater supply. This is the voltage multiplier for the bias, the control grid voltage supply. This pot is for adjusting the contrast on the LCD. This is the transformer connector, and this is the tube sockets connector that goes here to the switching matrix. And this is an encoder and button connection, and this is the buzzer connection, and this is the fan connection. Yeah, bump diffusing. Yeah, bump has been diffused. Hostage has been rescued. Counter-Strike at the bench. And let's take a look at the schematic. The schematic is pretty disorganized. It's not the way I draw schematics. It's like ravioli. So the heart of the device is the Atmega microcontroller. Let's move it the right way. Maybe putting the tester aside. So the main part is the microcontroller. This is the this is the heater supply. Not just the heater supply, but also the main logic supply with LM317. It supplies 5 volts DC. The other winding on the transformer is the plate supply. This circuit, it's the current measurement circuit, and for the plate supply, and for the screen grid, or the other way around. Let me take a closer look. Because this switches the systems for the plate supply. And yeah, this is the measurement range switching relay. This is the plate current converter, and here we've got the analog input on the MCU for measuring the plate current. This is the voltage divider for the plate voltage that also goes to an analog input of the MCU. This is the control input from the MCU, the pulse width modulation signal for adjusting the plate voltage. It is amplified by the LM358 operational amplifier, and with difference from the from the output voltage, controls the MOSFET through a level shifting transistor. A similar circuit we can see on the screen grid supply, not as advanced as you can see here, because it uses a single current range, doesn't deal with such big currents as the plate supply. This is the control grid voltage multiplier, and this is the measurement of the control grid voltage. This this is the driver chip that takes the PWM signal from the MCU and drives the voltage multiplier. It's for the control grid, and the other half is for the heater supply. And the heater supply goes from the 15 volts here, is passed through a MOSFET, and then it's rectified and filtered and fed to the tube's heater. All this while it's also measured on before the heater. The voltage is the voltage measurement divider is taken from before the heater, and after the heater there's a current measurement shunt resistor, or a bunch of resistors like you can see here. It's half an ohm with the values shown. All of those resistors are 1 ohm, so 4 of them parallel and series would be 1 ohm, and 2 of those groups would be half an ohm. and the 10k resistor going to another analog input on the microcontroller. Then the LCD display with backlight current limiting resistors and contrast adjustment potentiometers. And the circuitry that I omitted with Max 202, it's just an UART to RS-232 converter, because RS-232, I think it's a little bit obsolete. I'd rather connect USB to UART interface like CH340G, and that's pretty much it when it comes to the chip meter and how it works. Then the most important thing is done by the software, and I haven't really analyzed the source code yet. Yeah, mom's spaghetti. I just hope that my wiring doesn't look all that much like spaghetti. Might look for a different screw for the standoff. Oh, come on. Guns N' Roses went like, all you need is just a little patience. Why shouldn't the microcontroller be allowed in a vacuum tube tester? Let's not be all that orthodox with technology. And by the way, I think that at some point I'd like to modify the firmware on the microcontroller so that I can make this tube tester work with external control from a computer, so that I can feed it the tube parameters, the voltages, and then after the test is done, the tester would send the measurements over the UART back to the computer. Might be pretty useful for measuring the characteristics. A programmed vacuum tube characteristics meter with plotting all those characteristic curves. Wouldn't that be awesome? Huh. Still better than this one. That's nice. Found it. By the way, I haven't mentioned it, but this is the UART connection. And the meter is being recombobulated. Wi-Fi connected to the print press. Rocket science. If I was good at rocket science, I would go work for ESA. Because NASA is pretty far away from where I am. And time to put it back together. What if the space shuttle fire was actually the UFO? But do you mean Challenger or do you mean Columbia? And the critical part. After the cycle of discombobulation and recombobulation, it's starting up. Unzooming. By the way, you can see the power LED flicker. It's because it's powered from an unfiltered supply. From the same supply as the fan. Yeah, I forgot to start the measurement. Control grid voltage set. Plate voltage set. Screen grid voltage set. And the measurement is going. Interesting. Now the transconductance it shows it's 0.3. Got no idea what exactly is going on here. The transconductance is measured by changing the control grid voltage and measuring the plate current difference caused by the change in the control grid voltage. It's pretty inconsistent, and I think that the firmware in this meter could really use some better algorithm for rejecting the test data that are vastly incoherent with the remaining measurements, like ignoring the measurements that are clearly off, like if they were caused by some intermittent contact or something else. Now it shows 99.9 transconductance, which is bullshit. Now it times 19, which is way more realistic and consistent with the results that I had before. But still no internal resistance. The internal resistance is measured by then this is the dynamic resistance, and it's measured by changing the plate voltage while holding the grid voltages steady and measuring the difference in the plate current caused by changing the plate voltage by something like 10 volts. That's how the algorithm in the firmware does it, but it still doesn't have a safeguard against errors in the measurements themselves. Okay, that would be enough for this tube tester. It's pretty far from being perfect. Hot tube, hot tube. And you go off to the shelf. And the little amp comes back. Let's do a little bit of work on this one. Where did I have that socket wrench? Yeah, here it is. Careful not to lose them. And the first thing I would like to do is wiring the heaters. All the tubes here, they are the typical novel tubes that have heaters on the pins number 4 and 5. Yay! and because this amp uses DC 12.5 volts for the heaters, I will wire them in series by pairs, because those two bases are for EL84, and I will wire the EL84 in series. Then the heaters, of course. And the other tubes are ECC88 or E88CC or 6DJ8. Fume extractor to the rescue. Let's put them... I'd rather put them close to the middle, like 6 and 7. I will probably twist the wires, even though I'm using DC on this one. Yeah, L. I use it as much as I can. This should be pretty much enough. Is it a twister? Yeah! Gotta desolder this one so I can twist those wires. Come on, let's twist again, like we did last summer. Oh, let's twist again, like we did last year. Okay, that's 2 tubes to heat. And then the remaining two tubes. Yeah, round and round and round and round and round. And up and down. Loving the old music. I was always into the rock and roll music. Who cares? I was born in 1986. Learned the good stuff thanks to my father. He was pretty passionate about the music of his times. And of course he was a huge Beatles fan. Like he knew everything about the Beatles and had their discography. I guess that he treated the Beatles like I treated Depeche Mode. Like I was I had a real special interest for Depeche Mode when I was a kid. And I still like them. I won't be able to put two wires through those teeny tiny holes. I will try a different trick. Yeah. Sad story about Andy Fletcher. So many great musicians have died in the last few years. Like Prince and David Bowie and Vangelis, Olivia Newton-Jones. Just a whole generation passing away. But then there are new generations of musicians ready to take their place, make some change. because nothing in the music world should ever stay the same. And there are still bands doing the old school stuff, like rockabilly. So even though the old musicians are dying, I'm pretty sure that the genres that became a thing in the 50s and 60s and 70s and 80s, blah blah blah, they will stay and they will still inspire the future generations to make their own music. AI. Yeah, maybe those talking heads in Futurama. Who doesn't love Futurama? Hmm. Should I... check the pinout for EL84. The control grid is on pin number 2. That would be this one. Wondering if I could use the old Soviet paper and oil cap. I like those caps a lot. By the way, still about musicians, I would be very saddened to see Suzy Sue go. I saw a video, I don't remember what channel it was on, a video about Suzy and the Banshees today. One of my favorite bands, by the way. About how inspirational they were to other musicians who pretty much copied their style, especially when it comes to guitars. Yeah, and Suzy and the Banshees, they were basically they were the real pioneers of post-punk. Yeah, maybe I should do it this way. because both halves of the ECC will be wired in parallel, I can go from 1 and then put a bridge between 1 and 6. Yeah, holograms. I'm not exactly sure I want to live in that version of future. No, it's pretty depressive and dystopian already. Yeah, I guess let's do it this way, and I will use a zip tie to attach this capacitor and the other one on the opposite side. Yeah, I guess this will be the good way to do it. Automatic center punch action. No, I don't want to live in complete VR. I'd rather live in the reality, but live as an disembodied artificial intelligence capable of acquiring biological and electronic hosts. Okay, drilling action. debugging. Yeah, max suit. I want a suit of T-51B power armor. I really want that. The T-51B. And now it's time for some industrial grade hairdryer action. That's how you do it. None of that lighter rubbish. A dog riding alone in Tesla. Never even heard about that one. I may have to extend one of the leads on the capacitor. 100? Fallout allows up to 10. Yeah, I'm a huge fan of Fallout. Yeah, bye, Ray. Nice to see you. Bye. Okay, then the grid leak resistors on the power tubes. The 470K. It's 19 minutes to 3 a.m. here, and it will be pretty much time to wrap it up. Might show you the tubes lighting up. Because I've got this 12 volt supply on my bench, and this could be used for showing the tubes. Gotta find a barrel jack for 2.5. That's the one. Edward, I don't really understand what you're asking about. What is modeled after YouTube? Don't miss the spaceship. SpaceX or not. Okay, ready to see the test fire on the heater. Lights off. Interesting. Gotta use an adapter to save the day. And the tubes are lighting up. Yeah, messing with electronics. I'm building a very simple one. Nothing's gonna shock me because it's just the heater voltage I've got on this little sub chassis. But looking at it, you could see the tubes lighting up pretty nicely. Hello darkness, my old friend. I've come to talk with you again. Yeah. That song will always remind me of ContraPoints. Yeah, candles. And mouthfeel. Let's not go there. So the work that remains on this sub-chassis is adding the screen grid resistors on the power tubes, the cathode resistors and bypass capacitors on the cathode on the power tubes, plate and cathode and grid leak resistors on the driver tubes. It's very simple, and I've got, not sure where, but I had some pretty nice capacitors that I could use for cathode bypass. Not exactly sure when I had them. We'll have to take a look around the lab. Anyway, it's time to go back to the desk and wrap it up. I'm back. Yeah, electronics is fun. And it can be a lot more fun if you learn the basics of the electronics rather than just building stuff and programming with Arduinos and Raspberry Pi and other modern microcontroller platform because or a single board computer because it's important to work with the basics of electronics, even at the integrated circuit level, not going into discrete components, just staying at the integrated circuit level, like operational amplifiers and CMOS digital ICs. It's already pretty basic, and you just put a circuit together and test it and debug it and learn the principle of operation. There's no black box with who knows what going on inside, behind the scenes. It's all pretty transparent. As for how it operates, as for how it works, and getting a grip on the basics, this is the thing that lets you design circuits on your own. Like you no longer put together the building blocks, you make the building blocks and then put them together. You know how to design those building blocks, and you know what causes them to have the properties you desire. It's the same with programming. With code, you just don't copy-paste the code snippets you find on Stack Overflow and on other places. Just don't. If you want to solve a particular problem, get shit done, then okay, sure, why not? But if you want to understand the underlying principles, if you want to learn, then you have to take your time, analyze the things, and look for explanations. How things work like they do. I'm gonna drink some water. Having difficulty speaking when going dry. So I will probably make a video of this EL84 amp, making it and then testing it and putting the enclosure together and closing the project. And then I've got a radio or even two to restore. That I guess that I would like to do it on next weekend stream. Yeah, that's a Nuka-Cola. Wow, it's sparkling water. I just used bottles to get some sparkling water from a dispenser at a company I'm friends with. That's how I get the good stuff without having to buy it. And here's the meowing star. Yeah, I also like the sparkling water, and it can be had pretty easily if you take it from a machine that solves the carbon dioxide in tap water. Yeah, I'm not really a fan of sugary soda either, Al. I'd rather just drink water and also coffee, because I like coffee a lot. Back in the days I worked for an IT company, I used to drink 5 cups of coffee a day. Now I do with 1 large mug, but that's pretty much that. And sometimes I drink tea. Being a tea girl, you know. Okay, so it's 4 AM here in Central Europe, and it's time to say goodbye.